Welcome to the intersection of technology, cybersecurity, and society. Welcome to ITSP Magazine. You're listening to a new episode of Stories from Space podcast, where your host, Matthew Williams, examines the history of human spaceflight, the breakthroughs that revolutionized our understanding of the universe and our place in it, and the brave individuals who work tirelessly to advance the frontiers of our understanding. Knowledge is power, now more than ever.
The authors acknowledge that this podcast was recorded on the traditional, unceded lands of the Lekwungen peoples.
Hello, and welcome back to Stories from Space. I'm your host, Matt Williams, and today, in keeping with our series on rising stars in space exploration and national space programs, we're going to be taking a look at India, or as it's known, the Indian Space Research Organization, ISRO. In our previous segment, we looked at the history of China and its space program and how it evolved, and how certain commonalities and similarities were there between the development of NASA and the Soviet space program, and how this occurred within the context of the Cold War and was very much related to the development of nuclear weapons. Well, the same is largely true of India, with some caveats and exceptions. For example, India did not develop nuclear weapons and did not begin testing them until the mid-1990s. Nevertheless, like China, there are many interesting similarities with the Soviet efforts and NASA's efforts to realize the necessary rocket technology as well as propellants and engine technology, and conducting launch tests and developing heavier and heavier launch vehicles, with the intention of eventually sending humans to space, but also to the moon and beyond. And this is the current state of development of India's national space program. Much like China, they've got some very bold ambitions for the not-too-distant future. And the road that they took to get there, there's a lot of similarities. They followed a very similar developmental pathway to both the Soviets and NASA, and also China. And if all goes according to plan, they will have a space program in the coming decades that is likely to rival China's, as well as the European Space Agency's Roscosmos and NASA too. So it'll be very interesting to see what comes of that in terms of partnerships and also in terms of competition. In any case, to get into the history of the Indian space program, one first needs to go back to the early 20th century, which is where space research in India can be traced to through the work of scientists like Sisir Kumar Mitra, an Indian physicist who conducted ground-based radio experiments in Kolkata, where he used radio waves to probe Earth's ionosphere and learn more about the layers of the upper atmosphere. And this was followed shortly thereafter by the work of scientists like Sir Chandrasekhara Venkata Raman and Meghnad Saha. And it is Raman's work from which we now have the scientific principle known as the Raman effect, which describes the scattering of photons by matter and had a major influence on the emergence of quantum physics as a discipline. Meanwhile, Saha, he developed a theory of thermal ionization, which relates the spectral classes of stars to temperatures, which was foundational to how we classify stars today. And, as I said before, there were certain ties between the development of nuclear technology in India and its space program. This did not include attempts to develop long-range missiles, as was the case with the Soviets, the Americans, and China. Nevertheless, both programs, one for nuclear energy with the eventual intent of weaponization, and space exploration, these did emerge as a common program to modernize the country and achieve a number of firsts so as not to be left behind, and to ensure that India garnered respect as a modern nation, a modern state, which of course is very important to any newly independent country, which India became by 1947. Nevertheless, their efforts to realize a modern nuclear program began before this, in March 1944, when Indian nuclear physicist Homi Jehangir Bhabha launched India's three-stage nuclear power program. And this program consisted of, first, stage one, the development of a pressurized heavy water reactor, followed by stage two, the development of a fast breeder reactor, and finally stage three, the development of thorium-based reactors. And this program led to the first research reactor being developed in India by 1956, and the first plutonium reprocessing plant by 1964. However, the program would not reach its ultimate goal until the mid-1990s, by which time India began developing and testing nuclear weapons. In the meantime, a number of important developments happened in India, which allowed for the coordination of space research, and these happened around 1945 and after, and included Vikram Sarabhai founding the Physical Research Laboratory at Ahmedabad, and Homi Bhabha establishing the Tata Institute of Fundamental Research in Mumbai. And these institutes conducted studies involving cosmic radiation, which included particle experiments in the Kolar mines, which had once been purposed for mining gold, but had been repurposed for neutrino experiments, as well as studies of the upper atmosphere using high-altitude observatories and airborne instruments, which were designed to see how cosmic radiation affected Earth's atmosphere, and how Earth's magnetosphere also interacts with this radiation and filters most of it out. And then, in 1950, the Department of Atomic Energy was founded, with Bhabha as its secretary, which in turn began providing funding for space research. And this included numerous tests that were conducted into monitoring weather patterns on a global scale, and the study of Earth's magnetic field, or magnetosphere. By 1954, the Aryabhata Research Institute of Observational Sciences, or ARIES, was established in the foothills of the Himalayas. This institute is still in operation today and specializes in astronomy, solar physics, astrophysics, and atmospheric science. And last but not least, in 1957, the Jopal Rangapur Observatory was established at Osmania University in Hyderabad, which construction was completed on in 1968-69, which included its 48-inch telescope and two 12-inch telescopes. And this observatory was a place where astronomers from all over India came to conduct photometry and spectroscopy studies of stars, variable stars, comets, the moon, and the proper motion and velocity of stars, or astrometry. However, it was 1957, a pivotal year for many nations that decided to get involved in space, that India's space program really began to come together. It was during this year that the Soviet Union launched Sputnik 1, which not only inaugurated the Soviet space program, but inspired the creation of NASA and the Chinese space program. By 1962, Dr. Vikram Sarabhai, an Indian physicist and astronomer who initiated space research and helped develop India's nuclear power program, suggested to then Prime Minister Jawaharlal Nehru that a national space program for India was needed. In response, Prime Minister Nehru ordered the creation of the Indian National Committee for Space Research, or INCOSPAR. At this point, all activities relating to space technology and research continued to function under the auspices of the Department of Atomic Energy, once again demonstrating the interconnected nature of India's space program and attempts to realize nuclear power and nuclear weapons. INCOSPAR began recruiting people from the Indian ordnance factories in order to leverage their knowledge of propellants and advanced light materials that would go into building rockets, and it was an ordnance officer, Dr. Holnar Asapura Murthy, who became the first director of India's first launch facility, the Thumba Equatorial Rocket Launching Station, which was established in November 1963 in Thumba, near the southwestern tip of mainland India, and would go on to serve as the head of the Vikram Sarabhai Space Center. It was here that Murthy, known as one of the 7 pioneers of the Indian space program, oversaw the creation of sounding rockets, which were named Rohini, which began launching from 1967 onwards. These rockets conducted vital experiments and studies of Earth's upper atmosphere and marked the beginning of India's attempts to reach space. By 1969, Prime Minister Indira Gandhi created the Indian Space Research Organization, or ISRO, which became incorporated in 1972 into the Department of Space. This was India's first space commission and marked the beginning of an official national space program in India. During this time, India joined the Soviet program known as Intercosmos. It was formed in 1967 to assist Soviet allies with space activities, a program for space cooperation that was formed in 1967 by the Soviet Union to assist allies and friendly nations with their space activities. Through this program, the first Indian satellite, named Aryabhata, was launched into orbit by a Soviet rocket. The Soviets would remain the exclusive launcher of Indian satellites until the late 1970s. It was at this point, after many successful launches of sounding rockets, that the ISRO began to develop orbital launch vehicles. These efforts bore fruit when India successfully launched the first Satellite Launch Vehicle 3 rocket, a four-stage, all-solid propellant vehicle specifically designed to send small payloads, like communication satellites, to space. The development of the SLV-3 was paralleled by the development of the first SLV launch pad, known as the Sriharikota Range, located on an island off the coast of the Bay of Bengal. The station became operational in 1971, and by 2002 was renamed the Satish Dhawan Space Center, a tribute to former ISRO chairman Satish Dhawan. It was here that the SLV-3 made its first launch in 1979, carrying a Rohini science payload, which consisted of an experimental satellite. Unfortunately, the launch could not inject the satellite into its desired orbit. In 1980, India managed to successfully deploy a Rohini series satellite into orbit, becoming the seventh country to launch an artificial satellite to low Earth orbit, after the USSR, the US, France, the UK, China, and Japan. The Rohini satellite was also the third Indian satellite deployed to space, the previous two having been launched by Soviet rockets. Thanks to these achievements made between the late 60s and early 1980s, China, India, and the European Union would all go on to achieve great strides in space research and space exploration in the ensuing decades. For instance, during the 1980s, India experienced two major developments. This included their efforts to develop a medium lift launch vehicle capable of sending payloads to a sun-synchronous orbit. These efforts began in 1978 and led to the development of the Polar Satellite Launch Vehicle, or PSLV, by 1993. This four-stage solid propellant rocket is still in use, servicing the Indian government and commercial partners. In 1985, the ISRO established the Liquid Propulsion System Center, which began working on a more powerful engine known as the Vicus, which is based on the French Viking engine. By 1987, facilities that were designed to test liquid-fueled rocket engines were also established, as was the development and testing of various rocket engines and thrusters. Another noteworthy development was the development of ComSat technology, which began in the 1980s as part of the Indian National Satellite System. It's also during this time that the Indian Remote Sensing Program for Earth observation satellites began, which would lead to one of the largest satellite constellations in the world today. As of July 2023, India has launched a total of 431 satellites for 34 countries. By the mid-1990s, and with the success of the Polar Satellite Launch Vehicle, work began on a new geosynchronous satellite launch vehicle known as the GSLV. The design of the GSLV called for a three-stage rocket powered by cryogenic propellants. This would be the first rocket developed in India to do so, which is why development of the GSLV was paralleled by a project to develop the technology to store cryogenic propellants. At first, India attempted to obtain the technology for upper-stage cryogenic engines through the GlavCosmos program, a technology exchange program similar to Intercosmos, which was established by the Russian government after the fall of the Soviet Union. Unfortunately, these efforts were blocked by the U.S. between 1992 and 1994 on the basis that this technology exchange violated the Missile Technology Control Regime. As a result, India imported KVD-1 engines, which relied on liquid oxygen and liquid hydrogen, directly from Russia, which were used on the initial flights of the GSLV Mark I. By 1998, the U.S. imposed sanctions again in response to India's first nuclear tests, which were codenamed Operation Shakti. By 1999, as a result of the Kargil War between India and Pakistan, the U.S. refused to assist India with the development of global positioning system technology. This prompted the ISRO to develop its own satellite navigation systems in-house and led to the Indian National Navigation Satellite System, or IRNSS. This system is now known as the Navigation with India Constellation, or NAVIC, which has since expanded further. Sanctions imposed due to nuclear testing and border tensions between India and Pakistan expired after 1999. However, the ISRO remained sanctioned for sections of its space program between 1992 and 2011, at which point NASA reached out to the ISRO in the hopes of enlisting their help in NASA's Moon to Mars mission architecture. These attempts at cooperation were inspired, in large part, by India's own attempts to realize a lunar exploration program. This began in 2003 when Prime Minister Atal Vajpayee called for the creation of a robotic lunar exploration program, which was to be followed by a crewed program. In 2008, India launched its first lunar probe, the Chandrayaan-1 mission, which is Sanskrit for moon vehicle. This mission achieved some notable firsts, which included being the first satellite to verify the presence of water on the moon's surface. As the probe revealed, this water was largely concentrated in the polar regions, in particular the South Pole Aitken Basin, which has led to multiple space agencies planning on establishing habitats there in the coming years, not the least of which is NASA's Artemis Base Camp, China's International Lunar Research Station, and the European Space Agency's Moon Village. By 2013, the Mongolian mission, otherwise known as the Mars Orbiter mission, became the first Asian spacecraft to enter Martian orbit. This mission made India the first country to succeed at successfully sending a probe into Martian orbit on the first attempt. That same year, the ISRO succeeded in creating cryogenic engines for the upper stage of their GSLV rocket, making India the sixth country to have full launch capabilities. These efforts also led to work on a heavier lift launch vehicle in 2014, known as the Launch Vehicle Mark III. This three-stage medium lift rocket was designed for heavier satellites and will be vital to India's future human-rated space missions. On July 22, 2019, the Chandrayaan-2 mission launched. This consisted of a lunar orbiter, the Vikram lunar lander, and the Pragyan rover, all of which were developed entirely in India. This mission was responsible for assessing the composition of the lunar surface, scouting locations of water ice, all of which are in preparation for eventual crewed missions to the lunar surface. The Chandrayaan-2 orbiter is still operational in lunar orbit today. And on August 23, 2023, the Chandrayaan-3 mission successfully reached the moon and achieved India's first soft landing on the lunar surface. This made India the first nation to successfully land a spacecraft near the lunar South Pole. It is also notable that this mission orbited alongside Luna 25, a Russian orbiter and lander mission which attempted to beat the Chandrayaan-3 lander to the lunar surface. However, the Luna 25 suffered a failure in orbit and ended up crashing on the lunar surface. And on September 2, 2023, India launched its first Sun probe, the Aditya L1, aboard a PSLV rocket, which was then inserted at the L1 Lagrange point on January 6, 2024. This mission has been responsible for observing the dynamics of the Sun's chromosphere and corona, as well as the physical particle environment around it, the purpose of which is to study the origin, compositions, and dynamics of solar wind and its effects on space weather. In addition, The probe is tasked with determining the processes that take place in the various layers of the corona that lead to solar eruptions, otherwise known as solar flares, which also have a profound impact on space weather and can impact space missions and satellites operating in low Earth orbit and beyond. Other noteworthy accomplishments in this time include the ISRO setting a new record for the number of satellites deployed in a single launch. This took place on February 15, 2017, when an Indian launch vehicle deployed 104 satellites to low Earth orbit and overtook the previous record of 37 established by Roscosmos in June 2014. Meanwhile, efforts to realize India's first crewed space missions began in 2018. It was then, on December 25th, that the Indian government announced that the ISRO's first crewed mission to space would take place in 4 years. The Indian government further announced the 3-astronaut team that would be sent to orbit, which has since been augmented to 4. This includes Group Captain Prashanath Balakrishnan Nair, Group Captain Ajit Krishnan, Group Captain Angad Prathap, and Wing Commander Shubhranshu Shukya, all of whom were recruited by the ISRO from the Indian Air Force. This was followed by a similar announcement on August 15th by Prime Minister Narendra Modi. The launch would coincide with the 75th anniversary of Indian independence. Unfortunately, delays due to the COVID pandemic and other factors has pushed this launch date back to 2025. By September 2018, the 6th annual Bengaluru Space Expo took place, during which time the ISRO and its commercial arm, the Antrix Corporation, showcased the spacesuits that India's first vyomanauts would be taking to space. Vyomanut being derived from the Sanskrit term vyoman, meaning sky or space. They also showcased the crew escape module that would be taking the astronauts to low Earth orbit, which had been successfully tested in July of 2018. This program for crewed missions, known as Gangayaan, Sanskrit for celestial vehicle, currently consists of 3 proposed uncrewed flights in 2024, followed by the first crewed flight in 2025. In preparation, 2 of the astronauts flying aboard the first crewed mission will train at NASA facilities in preparation for the Axiom Mission 4 to the International Space Station. This private space flight will launch no earlier than spring 2025 and will be operated by Axiom Space using a SpaceX Crew Dragon spacecraft. In August of 2024, Shubhranshu Shukla was selected to be a member of the Axiom 4 mission crew, with Prashant Nair as his backup. On June 13, 2019, ISRO Chief Sivan Kailasavadivu announced India's plans for a space station in orbit, which would be assembled by 2035. The station would be a follow-up to the Gaganyaan space program and would be known as the Bharatiya Antariksa Station, which literally translated means Indian Space Station. Like its predecessors, Mir, the ISS, and the Tiangong Space Station, India's space station would consist of modules assembled in orbit, where rotating crews would perform vital science experiments and research that will help pave the way for missions beyond low Earth orbit. According to the details released by Sivan at the time, the station would be deployed 5 to 7 years after the completion of the Gangayaan program and would be capable of housing crews of 3 in low Earth orbit for 15 to 20 days at a time. Like Tiangong, this station could be a successor to the ISS, which is due to be retired by 2030, and which India never signed on to. And then, on October 7, 2023, Prime Minister Modi announced that India would be sending vyomanauts to the moon by 2040. This announcement took place during a review of the Gangayaan mission and its progress, during which it was stated that the station would be a key component to these future lunar plans. Shortly thereafter, on November 28th, during a symposium organized by the Indian Society of Geomatics and the Indian Society of Remote Sensing, ISRO Chairman Dr. Sridhara Somanath laid out a provisional roadmap for India's exploration of the moon, which included a possible lunar base established by 2047. So from this relatively brief appraisal, we can see how India's space program was shaped by many of the same factors that shaped those of the US, the Soviet Union and Russia, China, the European Space Agency, and other upstarts, which are now coming into focus. Much like China and the ESA, progress began incrementally during the 1950s and 60s, and by the 1980s there were several watershed moments that would lead to some spectacular developments by the turn of the century. While India is currently lagging behind China's space program by a few steps, it is clear that they intend to remedy this in the coming years and become a major power in space, one that could potentially rival China and maybe even NASA. Alternately, they could find themselves becoming partners with China or NASA, be it in lunar exploration or in all manners of space exploration and research. Needless to say, there is great potential for collaborative work when it comes to designing and launching satellites, robotic missions to other planets, crewed missions to orbit and to the moon, and the creation of a lunar base. At this juncture, it is unclear if the ISRO could become a signatory to the Artemis Accords or to the ILRS, or choose to go it alone. But as with so many other developments in space that have taken place in the past few decades, it is clear that when lunar bases are established and crewed missions to Mars take place that also result in the creation of long-duration habitats and facilities, it will be because of multiple space agencies operating independently or in collaboration with one another. In short, there's not going to be one or two flags visible on these facilities, but several. Thank you for listening to this latest installment on the space programs of the world. Join me soon where we will discuss the origins of NASA, the Soviet space program, the European Space Agency, the Canadian Space Agency, the Japanese Aerospace Exploration Agency, or JAXA, and other rising stars like the United Arab Emirates, Israel, South Africa, and more. In the meantime, thank you for listening. I'm Matt Williams, and this has been Stories from Space.
We hope you enjoyed this episode of Stories from Space podcast with Matthew Williams. If you learned something new and this podcast made you think, then share itspmagazine.com with your friends, family, and colleagues. If you represent a company and wish to associate your brand with our conversations, sponsor one or more of our podcast channels. We hope you will come back for more stories and follow us on our journey. You can always find us at the intersection of technology, cybersecurity, and society.